In this unit, we've been talking about different ways of factoring polynomials. In today's lesson, we're going to look at how to factor a very special polynomial called a difference of squares. In order to factor a difference of squares, you need to recall all of your perfect squares. We have those listed over here in the table on the right. Now, difference of squares has a very specific formula. It's used if you have the difference, so subtraction, of two perfect squares. So if you take this example here, x squared minus 25. Obviously, x squared is a perfect square, but we also know that 25 is a perfect square. So what we want to do once we recognize this is the difference of two perfect squares is we want to make this expression look the same way that it does in the formula. So essentially, we want to ask yourself, what exactly are we squaring here? Well, first we have x squared to get x squared, but what do you square to get 25? That would be a 5. So when you're comparing this to the formula, the x is your a value and the 5 is your b value. And all we're going to do is take those numbers and we're going to plug them into the formula. So the rest of the formula, we are going to be doing a minus b times a plus b. So plugging in our numbers, for a, we're going to write x, and for b, we're going to write 5. And again, for a, we're going to write x, and for b, we're going to write 5. So to factor this perfect square, we have x minus 5 times x plus 5. That is called difference of squares. Let's look at a few more examples. Number 2, we've got 49x squared minus 225y squared. Here we notice the x squared and the y squared right off the bat, but we also see 49 is a perfect square and 225 is a perfect square. So we're going to begin by making this expression look the same as it does in our formula. So I'm going to break this down. I want to know, what exactly am I squaring here? So what do you square to get 49x squared? Well, that would be 7x. 7 squared is 49 and x squared is x squared. For the second term, that would be 15y. 15 squared is 225 and y squared is y squared. So this gives us our value that we're going to plug in for a, and it also gives us the value that we're going to plug in for b. So if I write the formula, a minus b times a plus b, all we're going to do is go through and plug in the appropriate numbers. So I'm going to plug in the 7x for a, so this is going to be 7x minus, I'm going to plug in the 15y for b, so minus 15y. And then the same thing here, I'm going to plug in 7x plus 15y. That's how you factor the difference of squares. Our last example, we have 9x squared plus 36. We recognize that 9x squared is a perfect square because 3 squared is 9. We also recognize that 36 is a perfect square because 6 squared is 36. However, remember that the formula is called difference of squares. It only works if you have subtraction in the middle. This one has addition, so you cannot use difference of squares. So you look at it and you want to know if there's anything else you could possibly do. Remember, with two terms, you could always look for a greatest common factor. So is there anything that both terms are divisible by? Yeah, they're both divisible by 9, so we could divide everything by 9, which would leave behind x squared plus 4. Now, 4 is still a perfect square inside those parentheses, but since we're adding, we cannot use the difference of squares formula. So this is it. This is all the factoring that we can possibly do.